So guys, last time we made it into section 2.4. We don't do 2.5. It's not on the curriculum, right? I don't think so. Shouldn't be on that homework sheet, right? Well, all you got to do is look at the homework sheet. It'll keep you straight. What's up? No 2.5. Yeah. Let me see. Yeah. All right. So it shouldn't be a surprise. It's amazing. I told you everything I was going to do this semester. It's right there. First day I gave it to you. 2.4, we did the ratios, the proportions. That's where we learned about the one place that you can actually cross multiply and it works. Anywhere else you try to do it, it ain't going to work directly. So what situation? Can somebody give me an equation where I would use cross multiplication? Can somebody give me an equation?
X over 4.
2 over 7? Sure. Good, yeah. So I can use cross multiplication. That'll be 7x equals 10. Divide by 7. X is 10 over 7. I'm doing that problem right now with my Math 88 class. Cool. So that's the one time you can cross multiply is if I have a fraction equals a fraction. I like it. So you can use this idea. Here's something that you don't get told a lot. You can use this idea to verify equalities between fractions. Is this true? Is 3/7 equal to 9 over 21? Yes, because they just multiply times divided by 3. So one kind of nice way to check it is when I cross multiply, do I get a true statement? 3 times 21 is 63. 7 times 9 is check. So if I didn't know if two fractions were equal, I can set them equal, cross multiply. If those numbers don't come out the same, the fractions are not equal. Because if this equality is true, then cross multiplication should still be true. Because I just did something legal. The equation should be still true. If it's not true on this step, it wasn't true here. So the fractions would not be equal to each other. I like it. Okay, cool. That's a use for cross multiplication beyond just solving equations. Any questions from section 2.4? Have you guys gotten into section 2.4 yet? No?
I thought you got starts to 2.1, 2.2, 3.
Okay, you can get as far ahead as you want to. You don't have to be in 2.4 yet, but I'd say if you start it today, you're on track. So anything left over from section 2.4? I'm going to get into 2.6. All right, so 2.4 is all about ratios. For example, let's do one last example before I get too far away. This is a classic ratio proportion problem. If on a map the scale is 2 inches is the same as 7 miles. So if you look at a map, they got in the bottom, they got the scale. So it tells you like how much an inch, how much it actually is in real world terms in miles. And I have 2 towns that are, what you got, Jeff? I don't know, man. 60 miles apart in reality. How far apart will they be on the map? Yeah, so what can you set up? What ratios can you set up? So on the map, what's the ratio I can set up? Every 2 inches is 7 miles. So for every 2 inches on the map, that's 7 miles in reality. Yeah, because what I don't know, you got to put things in the right place. I've set up that inches are on top, the miles are on the bottom. So I got 60 miles, and I don't know how far apart that would be on the map. So you could have said 7 miles to 2 inches, but then up here would have been 60 miles and I don't know how many inches. Those are the same things. When you cross multiply, you get the exact same equation. As long as you keep that the way it goes, if it's inches on top, miles on the bottom, it's got to be inches on top, miles on the bottom, or vice versa. It must work. So if I solve this, what do I get? I get 120, 7x, divided by 7, whatever the hell that is. 17 point something. 1, 4 or something. 17.14 roughly? What? Inches, that's right. So I really need you to understand right now, I will be taking points off for not having units. I know students sometimes balk at that, but math is not just equations and numbers. Math is the whole thing. So you got to bring the units back in for it to make sense. Okay, so there are some problems like that. They got recipe problems, stuff like that. That's another place where ratios kind of come up. So many eggs to make so many pancakes, but I only have half as many eggs, so I'm going to make half as many pancakes. So shit, how much flour do I need? That kind of thing. Okay, so let me see. Stepping into section 2.6. Let me see how much you guys already know. Can you guys do this? Let me see where we are.
You want to graph? Yeah.
Not an XY graph, because I only got one variable up there, right? Number line. Number line represents all the x's, and I want all the x's that are at least 4. So how do you plot x equal 4? How do I plot x equals 4?
4.
Put a dot
on
on 4. I like it. But I don't want just equal to 4. I also want greater than 4. And real quick, what letter does that look like just kind of fell over? All right, so that's less than. Ooh, less than. All right. This one must be the other one. Must be greater than. You get the alligator and all that kind of crap, right? Mm-hmm. Have you ever heard that one? Alligator wants to eat the bigger thing, blah, 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 blah. That's kind of generalizing alligators. I don't know. They might have a taste. I don't know. This is bigger, but I like this one better. But the beautiful thing with what you got to do next is you can actually look at this as an arrow pointing in the direction you shade. Because I don't want to just shade on the 4, because what else is bigger than 4? 5. 7.1876662. 4.0000007. So I want to include every freaking point beyond that also. So that's what I want to do. That's how you graph that. How we doing so far? So I want to shade everything that makes this true. So notice how none of these are shaded, of course, because 3 is not at least 4. All right, let me stop there. Does this sound familiar at all?
Yeah.
Okay. So what would be the difference then between what we just did and if it was this instead? Is there a difference? I like it. I like it. So I still want all this here, right? Greater than 4. But do I shade the 4? No, I just have an open, unshaded circle because I only shade all the numbers that make that work. If I put a 4 in, does it work? Is 4 bigger than 4? That would be neat. Right? I made more money than you. You made $4 and I made $4. All right. Your money is bigger. I don't know. All right. I just want to see where you guys were just with this idea of graphing on a number line, shading the answers. Okay, does this all sound vaguely familiar? Vaguely? Okay. So what about this here? Try to graph that. This is going to be the last step in the problems, because of course they're going to start with things that I have to solve. This will be where I'm done solving, and now I have to graph them. Oh, cool. So what are you going to put on the negative 2?
Dark closed circle.
I like closed, shaded, dark, whatever you want to call it. What are you going to put on the 5?
Open circle.
And people get freaked out about this. All the answers have to be less than 5. And they have to be bigger than negative. I got to read it this way, don't I? So people often shade down here because they see that less than symbol, but negative 2 is less than my answers. So it is contained. So a better way to say this is all my answers are in between negative 2 and 5, including negative 2. So that's an in-between statement. So it's always going to make us what I call a sandwich. All right, these are my pieces of bread, and then I put the jelly in the middle. Alright, so let's look at what kind of, they're not going to be called equations anymore, because I wouldn't call this an equal sign. This is actually an unequal sign, an inequality. It is somehow not equal to, it is somehow bigger or smaller. Maybe it's possible for it to equal, but it's also possible for it to be bigger in this case. Okay, maybe. So the beautiful thing, for some of you guys, this might not be a beautiful thing. If you're able to solve an equation, you're completely able to solve an inequality with one little thing you got to be careful of. So let's do a nice one. So let's see, solve that and then try to graph it. And do what you said also. Yeah. So these solve just like equations. There's one little thing you got to be careful about that I haven't put in there yet. So you can, you're solving for the x values. The little thing is if you have to divide or multiply by negative, something gets freaky. And we'll talk about why that is. Otherwise, it's just like an equation. So yeah, you subtract x. So I get x minus 7 is less than 5. Is that cool? And then of course I add 7. X less than 12. How do I graph that? Please, dear God, whenever you graph, you don't have to have 0 show up. Have like x greater than 28, so it's like 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh my God. So a couple around it, that's fine. So what do I put on the 12?
Open circle.
Open circle. And then I shade which way?
Left.
I love it, the way it's pointing. So if the variable is on this side, you shade the way that's pointing. That's almost too nice to believe. Sure. Yes.
The power problem with this? Would it matter if you did the numbers or the x's first?
No, it doesn't matter.
Okay.
You just have to you can do them all at once, actually. I could have added 7 at the same time. As long as you take the x's one way and the numbers the other way, you're golden. So, I mean, I could put parentheses in there, you got to distribute and all this kind of crap, get your like terms together. Everything that has to do with equations goes into solving these. So what's the one difference? The one place you got to be careful? Dividing or multiplying by negative. And why the hell does that give me a problem? Well, let's see. Which one of these is bigger? 1 is. Alright. If I then divided both of those by -1, what does this become? Positive 2. What does that become? Which one's bigger? What happened? Sign change. And what is a variable? What is a variable? It's just a number that I don't know yet. So they have to act just like any other number would. So the same way as this, if I had -x less than 1, what do I have to do to solve that? Well, what do I do? Divide by -1. But I divided by a negative number, so then I have to flip that sign. Just like I had to do there. Because x could be 2, for example. Maybe. Let me give it to you a different way. Let's say I wanted negative something to be less than -4. Give me a number that I can put in there that would make it true. Is -3 less than -4? No. I could put a 5 in there. What else could I put in there? 6. Can I put a 4.1? Would that be alright? As long as the number you tell me is what? What is true about all those numbers you told me to put in there? They have to be bigger than 4. Really want this to make sense. So this equation should have an answer of x bigger than 4. We looked at it, it makes sense. All the numbers I can put in there to make this work are bigger than 4. So when I divide by -1, I have to flip the sign to make it match what I know is true. Now what's really going on is when you multiply or divide by a negative, you change the side of the number line the number is on. So -2 is over here. If I multiply by -1 or divide by -1, now it's 2. Now it's on the other side. So the order of the numbers changes. And that is what denotes order here, doesn't it? That says that was to the left of this. Now it's to the right of this. That's all that really says. All right, how are we doing? Maybe. So if I had this, let me be evil. Just be really evil. I'm telling you right now I'm being evil. How do I solve this? Divide by 3. So then how do I write the next thing? Bigger than, why didn't I switch the sign? Because I divided by a positive. I don't care if there's a negative in the problem somewhere. If I multiply or divide by a negative number, then the direction flips. I like it. Don't just go, there was a negative in there. I don't care. I didn't change things because I didn't divide or multiply by negative. I didn't switch the direction that things were in. Okay, maybe. Okay? So you try this one. What you got, Jeff? So solve and graph. Sure, I like it. That's what you guys can handle that. fraction, don't you? Okay. You put it in between two whole numbers and then go to 10. Who cares? Alright. So what do you guys get? X?
Oh, wait a minute.
Minus 6, I like it. So I get negative 2x. It's less than 11. Divide by negative 2. So x
equals
Bigger than.
Why does it flip? Because we divided by negative. If you divide or multiply by negative, you change the side of the number line, everything is on. So you've changed all the ordering. It's called a non-order preserving operation. Oh shit. So when I do that, I change the order. So then I better change the order. And what's this is a mixed number to make it easier to graph?
Negative 5.5.
Negative 5.5. So it's easier to graph. So I'm just going to put it in between negative. Where are you going to put that on the number line? Are you guys cool with that? 2 goes in 11.5 with 1 left over. Where do I put it on the number line? In between negative 6 and negative 5. So negative 6, negative 5. So right here I'm going to put what? Open because there's no equal sign, right? So I do not want to include 5.5, negative 5.5. And which way am I going to shade? Up. I like it. To the right. How do you check this kind of problem? Can I plug that number back in? Is that part of my answer? No, my answer has to be bigger than this. So actually, you've got how many numbers can you plug in to kind of check this? An infinite number thing. I can plug 0 in. Why would that work to check this sort of? It's not perfect, but it gets close. If I plug a 0 in, should it work? Yes, because it's part of my solutions, right? I've just shaded forever in that direction, and 0 is in there. So if I plug a 0 in, 0 minus 3 times 0 plus 2, what's this? Negative 6. Is that less than 5?
Yeah.
Check. Yay. So at least I know I shaded the right way. Okay, maybe. Alright, oops, shit. Took away the crap, sorry. So what about this here? What about it? I don't know. Jeez. Ooh, that's kind of gross. Sure. I'll make this come out nice. No more fractions for right now. Now, people freak out about this and they rewrite it with too much writing and crap. What do I always do when I'm solving something? Whatever I do to one side, I do to all the other sides. Now, I would never have said that before because we only had 2 sides before. How many sides do I have now? 3. I have the left side, the right side, and the inside, right? So what do I do? What's the first thing I do to start solving for x? What do I do? Add 2. So I better add 2. If I add 2 to the inside, I better add 2 to the right side and to the left side. Same thing as always. So real quick, is this true?
Yes.
Yes. If I subtract 2 only from these 2 sides, is this still true?
No.
Is that true? Is 1 less than 0? Oh shit, but if I subtract 2 from every side, is that still true? Yes, so you have to do the same thing to all sides in order for it to remain true. I like it. That shouldn't be that big of a deal. You don't have to rewrite this twice, like that's one problem and that's another problem. Even if you like doing that, try not to do that anymore. It's just extra writing. So what do I get here? 6 is less than 3x, which is less than 9. Divide by 3. 2.
Less than
Good. I don't flip because they didn't divide by negative.
x less than 3.
All right. Take a second and graph that. About 2, yeah, about 3. What do I put on both 2 and 3? Open circle. And then a shade in the middle. Put the jelly in the middle. Open circle sandwich. Now we are going to get to the point where we do this kind of thing in 2 dimensions. This is just 1 dimension right now. And that word dimension always sounds science fiction-y, but it's a dimension just means right now this is 1 dimension because it can only go left or right. If I add in the option to go up and down also, that's my XY plane. That's where I'm going to start graphing lines and stuff, right? Making XY tables and stuff like that. Does all sound familiar? A little bit. But I can do this kind of thing. I can get a graph, I can have a line, and then I can shade a side of it. Same way, I could just say, oh, I want all the points that are less than that line. Does that make sense? The same way we just did. And then I could have a whole other line and say, all right, I'm going to have this line, I'm going to shade above that. Now, what's that got to do with the real world? Well, the real world, this line might be number of people in an elevator, and this line might be the total weight in the elevator. So this would be my safe space. If I'm here, the elevator might plummet and we might all die. So in real life, these inequalities are used to find my safe space. If this has to do with electrical input or something, maybe if I'm there, something's going to blow up. So guess where I don't want to be? I don't want to be there. So I'm always kind of checking, where am I? Maybe the dial I look at actually checks to see, where am I? Am I in the safe space or not? And it goes to the red. If I'm up here, oh shit, let's not blow up. Let's go see what's going on. Maybe. So there is an actual physical application of this kind of idea. Okay. Let's see, blah, 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 blah. So chapter 3 is getting into graphing and the idea of functions. Right? So let me ask you this, just to kind of baby step in there. We'll leave a little early. I want you to see the main, most basic reason why we graph anything. Because I always have students like, why are we graphing this shit? Alright, well, if I ask you, give me some answers to this. Now, how many parts will every answer you give me have? Like, what does this say? What does that say in English? Don't say x plus y is 4. What's it say? No, that's an example of a working answer. What does it say? The sum of 2 numbers is 4. So give me 2 numbers that add to be 4. So obviously every answer you give me has to have how many parts to it? 2, because I have to have 2 numbers that make 4. So one answer would be 2, 2. And this is the way we chose to represent all the possible values, right? As a point. Give me another one that works. That's crazy. Another one. 4 and 0. Another one. I like it. Negative 1 and 5. Kick ass. What about 6.2 and negative 2.2? Sure. All right, Jeff. Whatever, man. Calm yourself down. Now, you can give me example answers. Now, let me ask you this. Give me all the answers to this. Thank you. It's totally possible. It's impossible to do it this way. My God. I would do it for the rest of my life, and then my kids would take over, and their kids would take over, and their kids would take over, and finally somebody would go, what the hell are we doing this shit? Right? So the quickest way to answer what are all the answers to this is to give somebody a graph and say, go find you here. I pointed you in the direction of all the answers, in the other direction. You go where you want to. Here they all are. And that is the most basic reason why we graph something, is it's a visual representation of all the freaking answers to this equation. Because how many answers will there be? Infinite number. Damn! So I don't know if you guys realize this. If I make this, why was this 3?